Chapter 3.7, Optimization Problems, Day 2. Now remember, optimization is where you're looking for the maximum or minimum of a situation. Some examples are you want to maximize profit in a business. You also want to minimize costs. All right? The steps for optimization, this is just a review. First off, define your variables. Assign variables to all your quantities. If possible, draw a picture. Step 2, you want to write a primary equation. This primary equation will be an equation for what needs to be optimized. So if they say find the maximum profit, you'll write a profit equation. If they say find the minimum area, you'll write an area equation. Usually it'll involve 2 or more variables. And we'll get rid of those extra variables with secondary equations. Right? Write a secondary equation that relates our other topics and substitute it into the primary equation to get rid of those extra variables. Once we have our primary equation down to one variable, determine values that make sense. It doesn't make sense to have negative cost. So you're looking at your domain. And finally, once you got everything done, optimize. Use the first derivative test to find the optimized value. So let's look at a few questions. Question 1. Which points on the graph of y equals 4 minus x squared are closest to the point 0, 2? Well, this is a good one to have a picture of. So we'll get out the graphing calculator. We'll graph y equals 4 minus x squared. I set my window, I zoomed to decimal, and then I changed my y to shift so I could see the 4 at the top. As we graph it, it takes looks like that. So we want to know which points on the graph of y equals 4 minus x are closest to the point 0, 2. Well, 0, 2 is this green dot right here, and we want to find the distance between 0, 2 and a point on the graph. Just any point in general, we'll call it xy. Well, if you remember back to geometry, the distance formula is kind of based off the Pythagorean theorem. So we're going to use the distance formula to find that distance. A squared plus b squared equals c squared. A, this distance here, is the distance of the x's, x minus 0, so x squared. The distance of the y's is right here, that's y minus 2, equals our distance squared. I'm going to say big D. Now this equation for distance has x and y. We want to get rid of one of those. And to get rid of one of those, we're going to use our secondary equation, which they gave us. There's our secondary equation. Our primary equation is for distance, because we want to know what's closest. So that means we want minimum distance. And our secondary equation is y equals 4 minus x squared. So let's plug that in. I'm going to switch it around. So I got d squared equals x squared plus quantity 4 minus x squared minus 2 squared. We'll clean that up a little bit. D squared equals x squared plus 2 minus x squared squared. And here we can go ahead and optimize. Let's take our derivative. I'm going to have to use a little implicit because I decided not to solve for d. So we'll do 2d prime equals 2x plus 2 times 2 minus x squared times negative 2x. And I want to know my derivative, so we'll divide by 2d. d prime equals something divided by 2d. I'm going to clean up the top a little bit. I'll distribute my negative 2x squared. So I got 2x. Negative 2x squared, that's negative 4x. Negative 4x times 2 is negative 8x. Negative 4x times negative x squared plus 4x cubed. All right. Cleaning up a little bit more, we'll combine some like terms. So we got 4x cubed minus 6x over 2d, and we want to set that equal to 0 to see where our critical numbers are. Now, when a fraction's equal to 0, it's what makes the top 0. So our critical number is anything that makes the top 0, anything that makes the bottom 0. The bottom is 2 times the distance. If we look back up at our picture up here, the distance between 0, 2 and that parabola will never be 0. You look around there, there's nowhere that that parabola touches the point 0, 2. So we do not need to worry about the bottom being 0. For domain, we should expect positive numbers because distance is always positive. And we'll go from there. So we'll take our top and set it equal to 0. 4x cubed minus 6x equals 0. We'll factor, we got 2x in common. And we're left with 2x squared minus 3 equals 0. So x equals 0 is a critical number. And x equals the square root of 3/2 is a critical number. I should say plus or minus, because the x value could be anywhere. The distance can't be negative, but the x value could be anywhere. So let's do a sign chart and find where we're closest. All right, so we go from negative square root of 3/2, 0, and positive square root of 3/2. Now, if we do some plugging into our derivative, d prime is 4x cubed minus 6x over 2d. Distance is always positive, so the bottom of a fraction will always be positive over here. And then in the top, pick a number less than negative 3, square root of negative 3/2. We'll say negative 10. Negative 10, 2 times negative 10, and I'm looking over at the factor form here. 2 times negative 10 is negative. 2 times negative 10 squared is positive, minus 3 is positive. So negative times positive will give us negative up top. Positive on bottom, this is negative. Pick a number between 0 and square root of 3/2. That should be negative 1. We substitute negative 1 in, we get negative 4 here plus 6. Negative 4 plus 6 is a positive, so this is positive. If we substitute 1 in for our interval right here, we substitute 1 in, this becomes 4. This becomes negative 6. 4 minus 6 is negative. So that's negative. And anything bigger than square root of 3 over 2, let's pick 100. 4 times 100 cubed is 40,000 or something around there. Minus 600 is positive. So this is positive. So the values that are closest are when x equals the negative square root of 3 over 2 or positive square root of 3 over 2. So when x is that, and then we just need to find out our y. So the points that's closest, let's go here. Then type in square root of 3 over 2. We get 2.5. So the values that are closest are xy equals negative square root of 3 over 2, 2.5, and Square root of 3 over 2, 2.5. All right, let's do one more. Find two numbers where the product is 192 and the sum of the first plus 3 times the second is a minimum. So the two numbers are x and y. The product is 192 and the sum of the first plus 3 times the second is a minimum. So the first plus 3 times the second is a minimum. That's our sum. Well, the product, xy, equals 192. Y equals 192x to the negative 1. If we substitute that in, x plus 3 times 192 is 576. X to the negative 1 equals our sum. We want to minimize that, so we'll do our derivative. S prime equals negative 576 x to the negative 2 plus 1. Set that equal to 0. Y equals 1 minus 576 over x squared. Top and bottom here by x squared. So we got 0 equals x squared minus 576 over x squared. Our critical numbers. What makes the top and bottom 0? X equals 0 from the bottom. X squared minus 576 equals 0. Subtract 576, square root it. You get 24. So x equals plus or minus 24. Do a sign chart. 0, negative 24. 24, we want it to be minimum, I believe. All right, so we're looking for a minimum. All right, so if I plug in negative 25 for this interval over here, negative 25 squared is bigger than 576, so the top will be positive, the bottom's always positive. So it's increasing there. Let's plug in negative 1. We get negative over positive. Plug in 2. We get negative over positive. And plug in negative over positive. Sorry. And then plug in 25 again. We get positive over positive. So the closest value is when x is 24. And so the two numbers, one is 24. The other number should multiply by 24 to get 192. So 192 divided by 24, the other number is 8. All right, so those are a few more examples of optimization. So just a quick review, the steps in optimization. Step 1, assign variables, draw a picture. Step 2, primary equation, which may have more than one variable in it. To get rid of those extra variables, you write a secondary equation. Once you've done that, decide on a domain that's suitable. Look at the situation, look at the formula, and then use the first derivative test to optimize.